Okay, this first question asks for slopes of secant lines. So whether it's a secant line or not, slopes are always the same. It's change in the y over the change in x. And so the slope is y2 minus y1 over x2 minus x1. So you just have to figure out what is the y and what is the x. So it's the volume that depends on time, and so the time is the x coordinate and the volume is the y coordinate. So our points are going to be points of the form that are volume comma time. And so our slope, the slope of our line, would be v2 minus v1 over t2 minus t1. And remember, when you're finding the slope, it doesn't make any difference which point you say is point 1 and which one is point 2. You'll get the same slope either way. So what a slope tells you is a rate of change. So a slope is a rate of change. So here, they're saying let P be the point 3,360. So that's this point right here. And we're supposed to find the slope of the secant line with two other points. So we're supposed to find the slope of the secant line that corresponds to when t is 6 and when it corresponds to t when t is 10. So P is the same for both of them. P is the point 8, 3360. And then for part A, we want to find the slope between P and the point 6, 3720. So we just find the slope in the usual way, and we would say 3720 minus 3360 over 6 minus 8 equals 360 over negative 2, or negative 180. And our units are the units of what the numerator is over the units of the denominator. The numerator is gallons, and the denominator is minutes. So this is gallons per minute. So it is between times 6 minutes and 8 minutes, it is losing the fluid at a rate of 186 gallons per minute. And then you'll do the same thing for the other point. Oops. So our next point is when t is 10. So when t is 10, we have the point 10, 3020, 3020. So we'll find the slope the same way. I'll take 3020 minus 3360 over 10 minus 8. And this time I get negative 340 over 2, which is negative 170 gallons per minute. And then part C says estimate the slope of the tangent line at t equals 8 by averaging your two answers alone. So just to remind you of what we're doing, if we have a function that looks like this, and we want to know the slope of the tangent line at a particular point, say this point right here, the tangent line looks like that. And we don't yet have a tool for finding that slope, but because it just has one point. We know how to find a slope if we have 2 points, but not if we only have 1 point yet. But what we do know how to do is find the slope with 2 points, and so I can take a point here, and well, what they're doing here is they're taking a point here and here, and finding the slope of this line, and a point on the other side, and this, and finding the slope of this line, and then averaging those two and seeing if the average would equal the slope of the tangent line. So that is one way to do it. Another way to do it, and we'll see in the next problem, is, say you've got your curve and you're wanting to find the slope of the tangent line. So you've got your curve and you're wanting to find the slope of the tangent line. What you do is you find the slope of one secant, and then you find the slope of another secant that's where the points are closer together, and then of another one where the points are closer together, and you keep going, and you just keep moving the secant points closer together, and you see if it looks like your slope is approaching some particular value. So in this particular one, we just have 2 points. The average of 2 points is the number in the middle of them. We had a negative 180 gallons per minute and negative 170 gallons per minute. So the average of those is negative 175 gallons per minute. And that would be an estimate of the slope at that point. Okay, so for this next one, a ball is shot straight up. Its height in feet is given by that. Compute the average velocity for the interval beginning at t equals 2 and lasting for those amount of times. So we are saying we want to know, so velocity is the slope of the position graph and average velocity V is position 2 minus position 1 over time 2 minus time 1. So the change in position over time. Well, if you look at a change in something over a change in something else, that looks like a slope, and sure enough it is. So your average velocity will be the slope of a secant. And your instantaneous velocity will be the slope of a tangent. So if it's a secant line, you have to have 2 points. So what are our 2 points? Well, we're starting at 2, and then we're ending sometime after it. And so our first, we've got 4 here, so our first one will start at 2 and end at 2.5. I don't have the position yet, but we'll get there. Our second secant line will start at 2 and it'll end at 2.1 because it says 0.5 seconds after 2 seconds. And then we have 2 comma, and then our next one will go to 2.05, and our last one will go to 2.01. Now we have to figure out what the y value is for each of these, or the y is the position. Well, they gave us the equation for the position. It's s of t equals 48t minus 16t squared. And so if you want to find the position at any time t, you just plug that time into this. So to find the position at time 2, I plug 2 in, and I get 48 times 2 minus 16 times 2 squared, which is 96 minus 64, which is 32. So at 2 minutes, or 2 seconds, it is 32 feet high. Oh no, these are seconds, not minutes. The last problem was minutes. Okay, now we need to find the height at these other times. So we need to find s of 2.5, S of 2.1, S of 2.05, and S of 2.01, and you do that just by plugging the number in to our function, which is right here, 48t minus 16t squared. So f of 2.5 is 48 times 2.5 minus 16 times 2.5 squared. And I get 20. And 30.24. And so for this one, what I did is I just plugged in 2.1 instead of 2.5 for t in 48t minus 16t squared. I'm just plugging in the time in for t. $31.16. And 31.8384. So all we did right there was we found the y value for each of our points. So now we know that at 2.5 it's at 20, at 2.1 it's at 30.24, at 2.05 it's at 31.16, and at 2.01 it's at 31.8384. So now we just need to find these four slopes. So m will equal S2 minus S1 over T2 minus T1. So for our first one, that would be 20 minus 32 over 2.5 minus 2. And I get negative 24. And then for the second one, where we would have 2.1 minus 2 what am I talking about? We would have the second distance, 30.24 minus 32. All over 2.1 minus 2. I get negative 17.6. And then for the third one, we would have 31.16 minus 32 over 2.05 minus 2. And for the last one, we would have 31.8384 minus 32 over 2.01 minus 2. I get minus 16.8. and I get negative 16.16. And these would all be in feet per second. And the question said, compute the average velocity for the, okay, so we computed the average velocity. It says use the results to estimate the instantaneous velocity. And so the instantaneous velocity is if we have this curve right here, and we're looking for the instantaneous velocity right there. The instantaneous velocity is the tangent line. And so what we've just done is we have found slopes of secant lines, but we're bringing that point in closer and closer and closer. And if you look at these numbers, you can say, well, it looks like maybe it's approaching negative 16. So our estimate is negative 16 feet per second. Pause this recording. Okay, so this next question asks us to evaluate some limits from looking at the graph. And so the first one says the limit as x approaches 2 from the left. So what you want to do is you find 2, you find where x equals 2, which is right here. And it says from the left. And so you go to the left of 2, and you go on that curve, and you travel along that curve until you get to 2. And then you ask yourself, well, what is the value when I get to 2? It doesn't matter if the function exists there or not, but it's just like you're going along, what would it be if it did exist? And this one is obviously going down to negative infinity. So from the left, how did I get this on here? Oh, okay. Yeah, so the limit as x approaches 2 from the left is negative infinity. Now, as x approaches 2 from the right, you do the same thing. You find 2, you go to the right of 2, and you travel along the curve until you get to 2, and you ask what is the value there. Well, we'll never actually get to 2 because we're going up to infinity. So this one is positive infinity. And when we have an asymptote, we could say that it's going to infinity if it's going to infinity on either side, but this one is not going to infinity or negative infinity, and the same on both sides. So since this is the two-sided limits are different, this does not exist. So when the limit as x approaches a from the right does not equal the limit as x approaches a from the left, the limit as x approaches a does not exist. Okay, what's the limit as x approaches 3 of g of x? So I come to look at 3, and I see that this is where x is 2, This is where x is 4. So this must be where x is 3. Well, there's nothing particularly weird going on there. If I travel along the graph as I'm coming from this direction, my y value here is 0. As I travel going in this direction, my y value when I get to 3 is 0. Remember, the limit is always a y value. And so as I travel along the curve, when I get to x equals 3, I actually have the answer, I have the value, and it is, I wonder why this is all moving around like that. That's weird. So if the function is just exists and there's nothing strange about it, then the limit is just equal to the y value at that point. Okay. So the limit as x approaches 3 is just 0. It's the y value when x is 3. So that's 0. And the last one says the limit as x approaches 5 from the right. So as x approaches 5 from the right. So where is 5? And why did I ask that? Is that what I asked? As x approaches 5 from the right. Okay. So if we look at where x is equal to 5, that is right here. Well, no, that's not it. No, there's an asymptote at 5. Oh, that's why I asked that one. Okay, so I thought I drew the asymptotes in on the graph, but I guess I didn't. Okay, so there's an asymptote at 5, and we can see as we're approaching 5 from the right, we're going up to positive infinity. So if we travel along on this graph, go to the right of 5, and travel along the graph, we're just going up and up and up. And so the limit as x approaches 5 from the right is going to be positive infinity. And I realize on this next question I put something in here that you haven't had yet, and I apologize for that. I got the questions from elsewhere, and I didn't pay attention. I took out some stuff that we hadn't had yet, and I'll explain what it is that you do need to know. So it says slope of a tangent line for f equals that function, let p11 be a point on the curve. So we could graph this function if we wanted to, and as a matter of fact, you always should. You should always take a look at what they look like. So handy. This test nav has an TI calculator and also just a baby Desmos right here. So we can put in y equals 2 over x plus 1. So that's what it looks like. Let P11 be a point on the curve. So 1, 1 is that point that just showed up in blue. And we want to compute the slope of the secant line PQ when Q has x coordinate 0.8 and again when it has x coordinate 1.2. Alright, so we know we have P is 1, 1. And then Q, the first time through, is going to be 0.8. We don't know the y value yet. That's part A. Part B, P is going to be still 1.1, and Q is going to be 1.2. Now to find the y value, you always plug into the function. The function gives you the y value. So y for part A will equal, so for part A, y will equal 2 over 0.8 plus 1. And for part B, y, this is really y2, because we have our first point, P is going to be x1, y1, and then Q is going to be x2, y2. So y2 will be 2 over 1.2 plus 1. So this will be 2 over 1.8. And this will be 2 over 2.2. And that is 1.11, repeating, and this is 0.90909. So those are just the y values here. So the y value for part A is 1.111, and the y value for part B is 0.90909, because that 0 would round up to a 1. And so the slope for part A would be 1.111 minus 1 over 0.8 minus 1, which is 0.111 over negative 0.2, which is negative 0.555. Negative 0.555. And for part B, we would have M equals 0.909 minus 1 over 1.2 minus 1, which is negative 0.090909 over 0.2, which is negative 0.4545. Alright, so this is this is the answer for part A, this is the answer for part B. Make sure those are the right answers. I cannot be trusted with doing calculations. Yep, okay, that's right. So now it says use these slopes to guess f prime of 1. So that was a mistake. I should have said, so that this means what I wanted to ask is use these to estimate the slope of the tangent line. Now what this notation is that's the notation for the derivative, and the derivative is the slope of the tangent line. So this f prime of 1 is asking you to find to estimate the slope of the tangent line at x equals 1. So use these to estimate the slope of the tangent line at x equals 1. So on one side we have 0.5555, and on the other side we have negative 0.4545. I mean, these are both negative. So a good guess would be negative 0.5. And then write the equation of the line at P. So an equation of a line, you need a point and a slope. P was given in the problem, it's the 0.11, and the slope we just said is negative 1/2. So the equation for a line is y minus y1 equals m times x minus x1. So y minus 1 equals negative 1/2 x minus 1. Y minus 1 equals negative 1/2 x plus 1. Y equals negative 1/2 x plus 2. That's not right. What did I do? Oh, I forgot to, oh, look at me. I told you I cannot be trusted. So there's plus 1/2. So plus 3/2. I think that's right. Okay. Alright, next problem. Limit via difference quotient. We're supposed to evaluate the limit as h approaches 0 of 5 plus h cubed minus 125 over h. There's a couple ways to do this. One way is just to plug in numbers that are very close to 0 and see what you get. So for example, if I say f of h equals 5 plus h cubed minus 125 over h, and I find f of 0.1, so I just plug in 0.1, so I'll take 5.1 cubed minus 125, get that value and divide it by 0.1. I get 76.51. If I plug in 0.01, so let's take 5.01 and subtract 125 and divide that by 0.01, I get 75.1501. If I take f of negative 0.1, So I take 4.9 cubed minus 125 over negative 0.1. I get negative no, I don't get it. I was like, why is it negative? It's not negative. It's 73.51. And if I take f of negative 0.01, that would be 4.99 cubed minus 125 over negative 0.01. I get 74.85. So what we're trying to find out is, and then if we look at a graph of this function, let's graph it. So we got values close to 75, so I just changed the y-axis so that it goes to 100. And so now I look at when we're at 5, and if I look at the graph exactly at 5, Desmos will tell me, Desmos does not know that it's undefined because it's finding points very close to it. But if I travel along the curve until I get close, and I look at the y values as I'm getting closer and closer to 5, where am I? Where's my 5? Where's my 5? 175? Why am I getting 75? Pause for a second. Yes, okay, so I was not looking at the limit as x approaches 5. Sorry, we're looking for the limit as x approaches 0. So as we're traveling along the curve and we're getting closer to 0, there we go. Okay, and then it is not defined at 0 yet. If I had time, I'd go and edit that out so you'd never know that I made that mistake. But right at 0, undefined. But as we're traveling along and we're getting closer to 0 and closer to 0 and closer to 0, looks like that's going to be 75. Okay, so that's another way to estimate it because, you can look at the graph, okay, and then also you can do it analytically. and we'll be practicing more with this later. So you would have to multiply out 5 plus h times 5 plus h times 5 plus h minus 125, the limit as h approaches 0, all over h, because if you just plug in 0, you would get 5 cubed minus 125, which is 0 over 0, which is indeterminate. So you have to do something to simplify it. And probably y'all don't know, did y'all ever do Pascal's triangle? It gives you the coefficients. If I'd have something like a plus b to the third, then I go to the third row here, and this would be 1 times a cubed plus 3 times a squared b plus 3 times ab squared plus 1. Oops. So this is just a little extra. You're not required to know that. But if you ever had to, say, multiply out, if you had to find out what x plus 2 to the 5th was by hand for some reason, don't know why you would do that. The way I'm getting these numbers on the triangle is I'm adding together the numbers that come in the row above it. Okay, so to the 5th, and then, so these are going to be the coefficients. It's 1, and it starts with x to the 5th plus 5, and then it'll be x to the 4th, 2 to the 1st. The sum of the exponents has to always be 5, plus 10, x to the 3rd, 2 squared, plus 10, x squared, 2 to the 3rd, plus 5, x to the 1st, 2 to the 4th, plus 1, 2 to the 5th. This is not related to this problem. This is just something interesting. That's called Pascal's triangle. So, but assuming that you had not seen that, let's first multiply together the first two. So I'd get 25 plus 10h plus h squared, and then I have to multiply that times 5 plus h minus 125 all over h, and then fascinating, but in the way. Okay, now I need to multiply everything in the first parentheses times everything in the second parentheses. So 25 times 5 is 125, plus 25 times h is 25h, 10h times 5 is 50h, 10h times h is 10h squared, h squared times 5 is 5h squared, h squared times h is h cubed, minus 125, all over h. And so the 125s cancel, and I have the limit as h approaches 0 of h cubed plus 15h squared plus 75h all over h, and then I can factor an h out of the top. And then I can cancel it with that h on the bottom. And then I have the limit as h approaches 0 of h squared plus 15h plus 75. And now if I plug in 0, I get 75, which is the same answer that we got by plugging in numbers close to 0 and by looking at the graph. But this is another way. And right now, for this quiz, it doesn't matter how you do it. And then just for those of you who are curious, so the way I would have done 5 plus h cubed is I know that's going to be 1 times 5 cubed plus 3 times 5 squared h to the first plus 3 times 5h squared plus h to the third using Pascal's triangle. So 125 plus 75h plus 15h squared plus h cubed. So I get the same answer, but I didn't have to like FOIL anything out. So that's kind of cool. Okay, so the answer was 75. Okay, and then one more question. Or two more questions. Yes, I skipped, that was number 6. I skipped number 5. So we're supposed to answer true or false. So A, the limit as x approaches -1 of f of x equals 0. That is false. Here's -1 right here. I can tell very clearly that the limit from the left and the limit from the right are not the same. So when the limit from the left does not equal the limit from the right, the limit does not exist. So the answer is false. F of -1 equals 2. F of -1 equals 2. That is true because that's where the solid dot is. The limit as x approaches 2.5 of f of x equals 5. So 2.5, so here's 2, so 2.5. Okay, that's where that open circle is. Okay, in the open circle, you would imagine as I travel along this curve, as I travel along the graph, and I'm getting closer to 2.5, what would the y value be when I get to 2.5? So when I get to 2.5, the y value is 5. It doesn't matter that at 2.5 it doesn't exist, just as long as it exists getting closer to it. And it's getting closer to it from both sides, so both sides have the same limit, and it is 5. So that is true. The limit as x approaches -1 from the left is 0. No. As we approach -1 from the left, so we travel along, we find where -1 is, it's right here. We travel along the curve going from the left until we get to -1. What's the y value there? It's 2. It is not 0. So this is false. So false, true, true, false. Okay, and then the last one. Okay, so here we have some more one-sided limits. So I want the limit as x approaches -1 from the left. So here's -1 from the left. What is the y value when I get to -1? So I travel from the left until I get to where x is -1. The y value there is 0. As I travel from the right, when I get to -1, the y value there is also 0. What's the value of the function at -1? The function at -1 is this solid dot right there. The function itself equals 2. So the limit exists because the left and right hand limits were the same. So the limit is 0. Even though the function is not 0, the limit is 0. And then as x approaches 2 from the right, so as x approaches, I don't think I meant to say 2. I have no idea what it is. I probably meant to say 1. So I'll just do a couple things. So as x approaches 2 from the right, it is approximately 2.5. So about 2.5. But let's just look at some others. Let's look at the limit as x approaches 1 from the right. So as I approach 1 from the right, the value is 1, 2, 3. The limit as x approaches 1 from the left of f of x is 2. So the limit as x approaches 1 does not exist. And then I also have the limit as x approaches 1, 2, 3, is that 3? 1, 2, 3. Limit as x approaches 3 from the left would be -infinity because it's going down to -infinity, and the limit as x approaches 3 from the right would be +infinity, not +8, +infinity. All right.